This is part of my next project. It is going to be a pair of mission side tables, and on the bottom they've got a very slight, subtle taper towards the bottom of the foot. There are plenty of ways in woodworking to make tapers, but it really comes down to a couple of different things. Do you want them to just be tapered? Do you want them to be all the same taper? And if you've got lots of identical items that are close together, you'll actually see those inconsistencies. So the easiest way, in my mind, is to use a table saw and a table saw jig. So in this video, I'm building a tapering jig for the table saw. Two things I want to get clear: this is using all of the micro jig match fit stuff. This isn't sponsored, this is all stuff I've bought. And the second thing is, it's pretty much their tapering jig, but I feel they didn't do a very good job of explaining why things are done that particular way or how they're done. So I'm going over that because it's actually a really solid jig. You can cut dovetails on the router in a single pass, but it's considerably more work for the router and the router bit because you have to do it in a single pass. You can't slowly raise the bit. In order to lessen the load on the router bit, I like to do relief cuts first. 2 passes widthwise at the table saw per channel is fast and gets enough clearance that the router bit eases through. There are 2 channels going along the length of the sled, so cut one side, flip the board and cut the other. Then adjust the fence for the second pass per channel. For the 4 short channels, the same thing can be done on the crosscut sled, but I just line up the layout lines on either side of the 0 clearance line on the sled for my spacing. The match fit system needs you to use a standard 1/2 inch by 3/8 inch 14-degree dovetail bit. They do have their own bit which adds some roundovers that does look nice, but it is not required. My router table fence does not have enough travel in it for the middle slots, so I ended up using the table saw fence instead. There isn't ever parallel issues with the router table and fence because of how the cutter works. For whatever reason, I find myself more comfortable with sleds that use a miter runner rather than just riding up against the fence. In this case, I'm using an aluminium miter bar, though I added wooden runners as I was unimpressed by the aluminium one. Washers space it above the table, then a few dabs of CA gives it a good bond. Then it can be flipped and screwed in more securely. The runner was offset so that the first cut removes just enough material to make a 0 clearance edge. For the stops, I'm using a scrap piece of plywood that I'm routing 2 1/4 inch through slots in. I route halfway on one side, then on the other, then flip the piece over and route all the way through, just like I did in the recent router edge guide. This scrap is then cut in half on the table saw. Then a corner cut is made using the crosscut sled. Then the remainder is removed at the bandsaw to leave an L-shaped bracket. Here's an example of the sled in use. The stock positions it, the match fit clamps secure it, and this allows me to easily flip the leg for the taper on the other face. Let's say I wanted to cut this taper here. It doesn't really matter whether it's a long taper, a short taper, whatever. It works exactly the same. First step is extend those marks to the side of the workpiece so that you can actually see them. Then place the marks in line with the edge of the jig. Because this was cut 0 clearance, we know that's where it's going to cut, so it's pretty simple. Next, take one of the L stops, slide it into the tracks and butt it up against the workpiece. If you can get it in the little L, great. If you can't, it doesn't really matter. If you're using 2 points of contact, 2 stops, it's going to be pretty easy to line up the next piece as well. You might be looking at the match fit hardware, which is this dovetail key with a threaded insert in it, and be thinking, I could probably 3D print those, and you can. I did exactly that. Australia Post were going to take an extra 3 or 4 days originally to deliver it, so I thought, well, I need this done now, and I printed it. I've used M6 because I had M6 knobs on hand, but if you are going to do it, I'd recommend M5 and probably thermosetting brass inserts into the 3D print rather than having a bolt head go through it. It'll just be a little bit nicer. The micro jig hardware isn't the cheapest thing in the world. It's not super expensive, but it is more expensive than 3D printing it. I'll probably just buy these. They fit nicer than my ones in the slots. That's just because I've used M6 hardware, and I probably don't need a whole heap of these because I can transfer the stuff from jig to jig just like I can with the clamps, and that's why I've gone with this system. I'm really happy with how this has turned out. The tapers are perfect. I didn't need to do a test cut on the legs at all, and they've all turned out perfect, all 8 of them. The sled could also be used for table saw jointing jig or straight line rip jig, but I have a jointer and I use a jigsaw if I need to put a straight edge on a slab or something like that, so I don't really know how it's going to function for that. I'll have a link to the products used and the original micro jig video of this, as well as a drawing for the dimensions that I've used, in the link below. Thanks for watching.